Hello and welcome back to the channel Computing underscore Teacher. And I hope you have been enjoying the videos that I've been posting um, related to Python programming, and most importantly, how to uh, create the approach or how to create the logic for the program is what the purpose of my videos are. So in this particular video, what I'm going to focus on is if you are an IBDP Computer Science student, right? So one of the topics that you're supposed to study is topic number 4, which is all about computational thinking. All right, computational thinking. Now, this computational thinking is all about how to create the logic, how to solve the problem. Okay, you're given a problem statement and you're presented a scenario, and then you have to create a program. So most importantly, the purpose of this particular unit is not to create a program, but to create the approach, but to create the logic for that particular problem statement, right? Now in doing so, we need to create something that will help me develop the program at the end. All right. And that particular step is something called as creating an algorithm. All right. So in this particular video, what I'm going to focus is on how we can write algorithms and what are the different ways an algorithm can be presented. Okay. So an algorithm is now, say for example, you're supposed to um, plan a birthday party. You want to plan out your own birthday party, right? So what are the different steps that you would take? You would first sit down with a pen and paper and decide on the menu, decide on the venue, decide on what are the different activities you would want to do with your friends, and then you would decide on the you'll create a list of your friends whom you would want to invite to your birthday party, and so on. So what you're going to do is you are writing down all of those as simple steps. All right, you're writing down as simple steps in whichever language you are convenient. Now here I'm not talking about any programming language as such. What I'm talking about is that I know English language, so I write it down in English language. All right, I know French, I can write it down in French. All right, so I'm talking about the language that you speak, that you're convenient with. So you write down the simple steps, 1 2 3 4 and so on, right? You write down the steps, right? And that forms an algorithm, and later you follow the steps, and then you will see that you have achieved what you wanted to achieve. All right, and in that way what happens is that you have clarity in your mind what happens next, right? For a simple problem like for a simple event like organizing a birthday party, it's not going to take much of an effort, right? But then if you wanted to do a big event management or something like that, then in that particular case it takes a lot of effort, and writing down those steps really helps you. So one way of doing it is writing it in simple English language. All right, now say for example, now I'm a programmer, I'm a program developer. All right, so first eventually what happens is that when you learn programming language, you first break down the problem statement into simpler steps. So one way is you write it down in your convenient language. Later what you do as step number 2, what you can actually do is you can write a pseudocode for it. Okay, you can write a pseudocode. Now what does a pseudocode mean? A pseudocode, pseudo means something that is not real. All right, code, a code that is not real. So what happens is that a pseudocode is a simplified version of your code, a simplified version your code of your code, which is more or less very close, which is, I mean, more or less very close to your what do you say, something like an English language or the language that you're convenient with. All right, but The difference here is that this code can be like um, it's like it will be much more easy for you to convert it into a programming code. All right, it's just not like simple English language. Okay, so say for example, an example of a pseudocode would be like my variable is say x, so I take x is equal to 5, say y is equal to 10, I uh, say a is equal to x plus y, and then I say print a. So this is not English language, neither this is a programming language. But what I have done is that I have framed a logic, I have framed the approach as to how I'm going to add it to numbers and store the value in a variable A. All right, so I'm using some very technical terms like variable, assigning values to the variables. We'll look into all of those. But you see, this is not a simple English language. We don't communicate with people like this. However, I'm writing this as a coded language, but this is something that cannot be executed by a computer compiler, a program compiler, or an interpreter. All right. So this is something which is called as a pseudocode, a code that is a non-executable. Okay. So a pseudocode is non-executable code. Okay. It cannot be executed, but it can give us an idea as to how the program is going to work, what are the different variables required, what values will be required, how we are going to solve the problem, and it gives us a complete uh, view of how the whole program is going to work. All right. Now, there is another way that an algorithm can be presented. And the other way that an algorithm can be presented is called as a flow chart. Okay, a flow chart. Now, a flow chart is the pictorial representation. Okay, it is the pictorial representation. That means in the form of a picture representation. All right, it's in the form of a picture. Here we are writing it in words, and in the case of a flowchart, what we will do is we'll draw it. Like say for example, I want to convert this particular pseudocode in the form of a flowchart. So there are special symbols. We'll see later subsequent videos that how flowcharts are created, right? And all of these will have a special symbol for it. So this is for assigning x is equal to 5, y is equal to 10. And then what I'm doing is I'm saying a is equal to x plus y. And then I am printing the value of a. All right. And then what I do is I stop it. All right. Now you see each and every statement that has been written over here is in this particular flowchart. This also represents the flow of the same program, but it is slightly different. And the difference is that each of this is represented in a particular box. So for printing out something, I have used a parallelogram. For showing the process part of it, I have used a rectangle, right? And I've started the program with these rounded rectangles probably, and sometimes oval is also used. And the flow of this particular program is being shown using the flow chart. Sorry, the flow diagrams or the flow arrows. All right. So if I start here, I know that, yeah, I will follow this particular arrow, and then I go here. Here, there are two variables x and y that are getting the values 5 and 10 respectively. And then I follow this particular path. I follow the arrow. All right. So this pictorial representation called as flowchart again is providing the idea. It is providing the knowledge about how the logic is to be framed for that particular problem statement wherein two variables or two values have to be added. Okay. So this is an introduction to flowcharts, pseudocodes or algorithms for that matter. So in this particular video, I am going to further focus on pseudocodes. All right, so I'm going to focus on pseudocodes. All right, so let's now look at pseudocodes. Okay, pseudocodes, the fake codes or non-executable codes. All right. Now, all of this is in terms of your IBDP computer science curriculum. All right. Okay. Now, in the previous explanations, I have used some terms like variables, constants, and things like that, right? So don't get overwhelmed with all of those. These are very, very simple terms to understand, but yet very critical to understand, because throughout our pseudocodes, these terms will be used very, very commonly. Okay, so let us now first take up the first term, variable. Okay, variable. Okay, take a moment, think. What does a variable mean? Variable, something that varies. Varies. Okay, a quantity that changes. So this can be the simplest way a variable can be defined. A quantity that changes, varies. It's a variable. All right. Now the variable in pseudocodes will be represented by an English letter. All right. Or any combinations of letters. Now there are certain rules that need to be followed. Okay. So the rules that we will follow is that according to your IBDP curriculum, any variable will be written using capital letter. Okay, it will be written using capital letters. X, A, place. All right. Say for example, num underscore one, things like that. All right. So first, all in capital letters. Now, why this is done is so that we can differentiate our variables with the other keywords. Okay, so that's number one. The second number one rule is that a variable cannot start with a number. Cannot start with a number. A variable cannot start with a number. Say for example, if I want to start a variable, say I cannot write one underscore num. Okay, this is illegal. Okay, this is not allowed, right? This is of course allowed. Okay, I cannot write 2 num. Okay, this is not allowed. This is rule number 2. Okay, now let's go to rule number 3. Rule number 3 states that only underscore is allowed as a special character. Underscore is allowed. Underscore is allowed as a special character. Okay, as a special character. Okay, that does not mean that I can start a variable name with underscore. Okay, this is invalid. Okay, num underscore 2, this is valid. All right, I can have it in between. Say for example, country underscore capital. Okay, so these are some of the rules that we need to follow while we are writing the names of our variable. Okay, now we know how to name the variable, but what is the purpose of the variables? Why do we require a variable in the first place? Okay, that definitely must be haunting you. So what is the purpose? Now when we say that a variable is a quantity that changes, that means a variable is something that contains a quantity in it. So say for example, I have created a variable called as x. So what happens that in the memory of the computer, a location is given a name x. A location is provided by the name x. Now this is the container. Okay, so this is the container. this is going to contain a value. So if I say that this particular variable x will contain the value 10, so in the memory for this particular address location called as x, or the variable x, 10 will be stored here. So whenever I refer this particular variable x, 10 is something that is going to be worked with. All right. So if I say I want to print the value of x, x will not be printed, but 10 will be printed. Why? Because the variable x contains the value 10. So if I write print the value of x, what will happen is that I'll get the output as 10. I'll get the output as 10. Why? Because this particular container contains the value 10 in it, and it is referenced by the variable name x. All right. So this is the purpose of variable. I can store uh, values in it. Okay. And it is not necessary that I can store only numbers in it. I can store, like say for example, if I say x is equal to 5.7, so this is a fractional number that I have stored. Okay, so if I say that x is equal to, say for example, ICT, all right, or say for example, if I say x is equal to computing underscore teacher, or say for example, I say that AB is equal to a small a. So here you notice that I have used different types, different ways that I am storing the different values in that particular variable. So here the variable x is used to store the value 5, which is an integer type of a value, which is a number. Here the variable x is being stored to used to store 5.7. Now this is a fractional value with decimal number. Here x is being used to store the value ICT, which is within double quotes. You need to notice this, which is inside the double quotes, double quotation marks. And therefore, this is a string type of a variable, which is a collection of sequence of characters stored together. We'll talk about strings later, and it's a different topic altogether, right? Over here, this string, which is of computing underscore teacher, which is again against within double quotes, right? And here in this particular variable AB, I am storing one single character, and therefore I am putting it inside one single quote. So this is a character type. This one is a string type. So these are the different data types that can be stored, and we'll come talk about it later. All right. So this is the purpose of variables, and how variables are named, and how variables can be given its values, right? Now, at this particular point, let us also understand something, that I have given this value x is equal to 5. So how does this particular statement work? All right. Now, what is 5? A 5 is a quantity that is a constant. Okay. It does not change. A 5, the magnitude of 5 will always remain 5. 5 balls means you count them to be 5. All right. It's constant. It cannot change. But x, for this particular instance, it is holding 5. In another instant, it can hold 5.7 or something like that. And therefore, x is the variable. All right. But how does this value 5 get stored inside the variable x? This is because of this equal to sign that I'm using over here. All right. Let me write it a little clearly. This equal to symbol that I am using over here. All right. So what happens is that whatever is the value on the right hand side will be stored inside the left hand side. And this is a rule. Any value on the right hand side will always get stored in the left hand side variable. Okay. If I write 5 is equal to x, this is wrong. Okay. Let me use another variable. The x and the cross wrong, both are looking same. So if I write y, 5 is equal to y, so this is something that is absolutely wrong. I cannot use it. Okay. Mathematically, it is right. 5 is equal to y, or y is equal to 5. Mathematically, in algebra, you can write it. Not a problem at all. But then in computing, This creates an ambiguous situation. It does not know which is the variable, which one is the constant in this particular case. However, if you write y is equal to 5, this assignment operator, this is called as the assignment operator, this equal to sign, it will assign the value 5 to the variable y. All right, so this is called as assignment. Assignment, assignment. This is called as assignment. So here I'm assigning the value 5 to the variable y. All right, so this is how it is supposed to be done. So this is about the complete concept about variables and how the values to variables can be assigned. All right, so that's all in this particular video, the concept about variables and constants. In the next video, we will talk about the different data types that can be stored in the variables. Okay, goodbye for now. Happy learning.